how much does one sucrose molecule weigh in grams? So how much does one sucrose weigh in grams? So with this, we need to find out the, I guess, the atomic mass. It says one sucrose, okay, not even one mole of it, one sucrose molecule. So this is going to get really tricky because we're actually going to be dealing with, first we need to find the moles, and we have to multiply that by Avogadro's number, because that's based on how many particles we have. So let's first solve it, and let's see what we're dealing with here. So first, to find the weight in grams per mole, we have C12H22O11 for sucrose, okay? So now to get the constituents, all right, we have 12 carbons, 22 hydrogens, and 11, okay, and 11 oxygens, okay? So now let's see what that equals. We have 12 times, according to the periodic table, 12.011 plus 22, whoops, 12 carbon is, just want to find that first. That would be 144.12, and hydrogen, 22 times 1.008, 22.176, and the oxygen, 15.999 times 11, we have 175.989. So now let's add up all these three together. We get 342.285 grams per mole. Okay? And now we need to find out how much for one sucrose. Avogadro's number is known as 6.022 times 10 to the 23rd particles per mole. So actually, in order to be able to make sure that certain things cancel out, we want to know grams per particle. That is what we want right there, okay? Specifically, the particle. So we have 342.285 grams per mole times 6, whoops, sorry, wrong area, 1 mole, which is N, well, let's write it out, 1 mole, okay, and it's 6.022 times 10 to the 10 to the 23rd particles. So now the moles definitely cancel out. So now we have this divided by 6.022 e23rd. And now we know that one sucrose molecule, okay, not a mole, but a molecule of sucrose would weigh 5.68 times 10 to the negative 22 grams per particle. Okay? You have to make sure you read the question carefully and know exactly what they're asking for here. Alright? So if I went back to this, how much does one sucrose molecule weigh? We got that, and then we were able to get the molar mass, and then because of that, we were able to now divide that by Avogadro's number. We got 5.68 times 10 to the negative 22, which is exactly what I got as well. This is indeed correct. So the trick here is just making sure that you read it and really understand what they're asking for, so that we don't stop too early, like for example just ending with the moles. Okay. So let's move now to question number 17.